Sequences. Why is 4, 10, 16, 22 considered an arithmetic sequence? Alright, so if I continued this particular sequence, 1, 3, 5, 7, you can probably see that there's a pattern going on here, and my next number is going to be a 9, followed by an 11, followed by a 13 and 15, and it looks like each sequence, what I'm doing is I'm adding 2 to the previous term. Okay, so there's a sequence for you as an example of a sequence. Let me go and move it down here. I've got 1, 1.25, 1.50, 1.75. My next number should be 2, followed by 2.25. It looks like I'm going to add 0.25, or a quarter if you think of it as money, to the previous term. So these right here are examples of arithmetic sequences. And here are some definitions for you. So a sequence is an ordered list of numbers. The term is each number in the sequence. So for instance, this is a term, the first term, the second term, the third, fourth, fifth, sixth term, right? Or up here, the first, second, third, fourth, fifth, sixth term. And the arithmetic sequence, it's a type of sequence. It's when each term is found by adding the same number to the previous term. So whenever I add the same amount to the previous term, new numbers show up. That's considered an arithmetic sequence. So let's go for an example here. Describe the relationship in the arithmetic sequence, then write the next 3 terms. So let's take a look. We got 4, 7, 10, 13. So simple enough, we just find the pattern. Say, look, it's going up by 3 each time, right? Add 3 to it, add 3, add 3. So each term is found by adding 3 to the previous. Okay, simple enough. Next part is, what are the next 3? Well, if I add 3, I get 16. Add 3 more, I get 19. Add 3 more, I get 22. So those are the next 3 terms. Let's take a look at another example. But this one, 0.6, 1.1, 1.6, 2.1. What's going on here? So find the pattern. Looks like it's adding by 0.5 each term, so each term is found by adding 0.5 or 5/10 to the previous. What's the next 3? Well, if I keep adding 0.5 each time, I'm going to go to 2.6, 3.1, 3.6, and so on and so forth. So those are the next 3 terms. So that's simple enough as it is, right? We're just basically finding the patterns, figuring out what the pattern is, just like the one above, and then continuing that pattern as it goes. So now I want to write an algebraic expression to be able to solve for this. Instead of having to, oh, I need to know what the 8th term is. Okay, I got to keep adding until I get there. There's a faster way of getting there. Okay, that's using algebraic expressions. So let's consider the sequence. Let's go back to 3, 6, 9, and 12. This is an arithmetic sequence. We're adding 3 to each time to get the next number. Okay, so 3 would be the first position. 6 would be the second position. 9 would be the third. And 12 would be the 4th position, right? The terms, the first, the second, the third, the 4th terms. So what I'm going to do here is I'm going to say, look, the positions, I'm going to go ahead and put those written down for me right there. Position number 1, okay? I want to figure out, the value of the term. Well, let me borrow this, change this for just a second. Okay, sorry, I forgot I used a different example. So looking at the positions, the first position was 3, the second position was 6, the third position was 9, and the 4th was 12. Those are the numbers I've used. Looks like they were going up by 3, just like we were doing before, finding the pattern as these went up by 1. So let's think, what is the operation that's happening here? Well, let's see, I'm having something. I'm taking this first position. How can I use 1 to get to 3? So I can go 1 times it by 3, and I get 3. All right. What about 3 times 2 will give me 6. Next going to be 3 times 3 would give me 9, and 3 times 4 would give me 12. So what I'm doing is I'm taking 3, and I'm multiplying by the position number, and that'll get me my following answer. So what I can do is I can make a generalization, and I can say, look, the expression I could use is 3 times whatever position you're trying to find out. Right? If I want to know the 50th or 100th, I would just substitute that in for n, and I could tell you what the value of the term is. Let's take a look at an example. to explore this more. So you might be saying, say what? Let's see that one more time. Okay, so if a pattern continues, what's the algebraic expression that you can use to find the 50th figure? So here we go. I've got the first picture, I've got 3 little dots. The second, I've got 6. And the third, I've got 9. So figure this out here. The first position, I had 3 dots. The second position, I had 6 dots. The third position, I have 9 dots, right? So what's the operations? Well, let's take a look. Over here, these are increasing by 1. Okay. Over here, this is increasing by 3 again. Okay. So how would I get these? Just apply it. You say, okay, look, it's going up by 3 each time. So I can go, what times 1 gives me 3? Well, that would be 3 times 1 gives me 3. Or 3 times 2 this time gives me 6. 3 times 3 gives me 9. So I'm just taking 3 and I'm timesing it by the certain position number. So if I'm asked to figure out what the 50th term is, 50th position, I'm just going to go 3 times 50, which I would find out is 150 of those little dots. Do I have to draw it? No, but I'm just showing you that's how you would solve that problem. All right, that's it for today's notes. Make sure you write your 3 questions in your summary. Be prepared for tomorrow.